There was a young fellow from Trinity who took the square root of infinity, but the number of digits gave him the fidgets. He dropped math and took up divinity. Hi children, Hariom everyone. How are you all? Back again to the second term of the academic year. Welcome back. Today's topic is squares and square roots. Shall we start the session with prayer?
सहनाववतु सहनौ भुनक्तु सह वीर्यङ्करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः हरि ओम् श्रीगुरुभ्यो नमः हरि ओम्
Today, let us learn squares of numbers. Before we start, we need to understand the meaning of squaring a number. When we multiply the number by itself, we obtain the square of that number. Let us take the number 6. When we multiply 6 by itself, we get the answer as 36. That means 36 is the square of 6. We write it as 6 into 6, which is equal to 6 raised to power of 2 is equal to 36. We read it as 6 square or 6 raised to the power of 2 is 36. Now, let us find what is 15 square. 15 square is equal to 15 into 15, which is equal to 225. So, 15 square is 225. Now, quickly find the square of 70. Here, first find the square of 7. That is, 7 into 7, which is equal to 49. Now, place 2 zeros after 49. So, we get the answer as 4,900. Thus, 70 square is equal to 4,900.
In this video, we are going to learn what are square numbers. We all know what is an area of a square, right? So here is a square where each side is 4 centimeter long. So what would be its area? We know if we divide this square into different smaller squares, each of 1 centimeter by 1 centimeter, then on this 4 centimeter there will be 4 such squares, and same way on this side also there will be 4 such squares rows. So total would be 16 such squares, right? So the area of this square is 16 square centimeters. So area of square, we know the formula is side into side, right? So this is all we have learned in geometry in our previous videos, correct? So if a square is having a side of 1 centimeter, its area would be side into side, that is 1 into 1, that is 1 centimeter square. If it's 2 centimeter, it's going to be 2 into 2, that is 4 centimeter square. If area of a square with side as 5 centimeter, the area would be 5 into 5, that is 25 centimeter square. Or to put it generically, if there is a square with n centimeter as the sides, then its area would be n into n. That's called as n square centimeter square, right? So 1, 4, 9, whatever we see here, 1, 4, 9, 16, 25, we can keep extending this. All these are known as square numbers. That is, it's a square of a number. So how do we represent a square of a number? When we say 1 square, which really means 1 into 1, that is a number by itself, 1 into 1, it's represented 1, and we write 2 in a very small top left corner in smaller size. 2 square, same way, 2 square means 2 as a number multiplied by itself, 2 into 2. So it becomes 2, and then we write a small 2. 3 square, 3 is the number multiplied by itself, 3, small 2 at the top of it. So to represent any number square, we just write that number like 4, and we write a 2 on top of it. That is that 2, which is the power is saying 4 multiplied by 4. Make sense? So we represented the square of a number by putting a small 2 on the top right. So now let's take some more example. On the left side, I have certain numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And right side I have written it squares. Square means the same number multiplied by itself. So 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9, and so on. 8 into 8 is 64, 9 into 9 is 81, and 10 into 10 is 100. Right? So let's look at certain properties of these square numbers. So here is a number, and here are its squares. So if you observe all these squares, you will never find a square number ending with 2 or 3 or 7 or 8 in the ones place. See, this is having 1, this is having 4, 9, 6, 5, again 6, 9, 4, 1 or 0. You will not find the squares ending with 2 or 3 or 7 or 8. That is, in ones place you won't find this in the square numbers. You can keep on doing for any number. You can take a big number also. You will find other numbers, but not 2, 3, 7 or 1 in the ones place. So this is one important property of a square number. If you are given suddenly a number 162, you can say, is it a square number? That is it a square of some number? No, because it's ending with 2. Say I say 363. No, it's ending with 3. So it cannot be a square number. Let's look at another property. If a number ends with 1 or 9 in units place, like here I have taken certain example, number like 1, 9, 11, 19, 21, 29, I can go 31, 39, 441, 449. If a number ends with 1 or 9 in units place, then its square always ends with 1. Here you can see 11 into 11 is 121, 19 into 19 is 361. So the squares are all ending with 1. So if the number ends with 1 or 9, its square ends with 1. Why is it so? We know just purely by the rules of multiplication. Say I take an example 19 into 19. So I write, how do we do 2-digit multiplication? We write 19 into 19, and then we do single digit at a time, right? So we do 9 into 9, 81. Then 9 into 1 is 9 plus 8 is 17. Then next we leave it blank, or we can put an X there or 0. Then we do 1 into 9, 9. 1 into 1, 1. Then we sum it up. So when we do the sum, you see 1 plus 0 is 1, and rest you keep on doing. So if any number is ending with 9s, then 9 into 9 is always 81. It can be a very big number also. 2359 into 2359. Always 9 into 9 will be 81. And in the next step, there will be zeros here. So when you add them, it will always be 1. Exactly the same thing holds true for ones. So suppose the number was 21 into 21. 1 into 1 will be 1. And that is the reason any number which is ending with 1 or 9 in their ones place will always be having 1 in their squares place. Make sense? Let's take another property on similar lines. If a number ends with 4 or 6, then its squares always ends with 6. As you can see here, 26 into 26 is 676. 24 into 24 is 576. And why is that? Again, do a simple multiplication and you'll know why it's that case. Let's take 24 into 24. Just do a normal 2-digit multiplication. How do you do? Just do the first step. 4 into 4 is going to be 16, so 6 will come here and 1 will go and carry over. And in the second step, there won't be any number here. It will be blank or 0 here. So 6 plus 0 will be 6. So the ones place in this square number, that is 24 into 24's product, will always be 6. If I take a big number, 32574 into 32574, in the ones place in the product will be a 6, because 4 into 4 is a 16, and 6 you write here and 1 goes somewhere in the top. Rest of the numbers can be in anything. But the property is saying if the number ends with 4 or 6 in the units place, then its square will end with 6 in the units place. Make sense? One more property, if the number ends with 0, then its square will have the double number of zeros. What does it mean? Let's take an example. 10 into 10 is 100, so it ends with 1 0, and in the square you see 2 zeros. 30 square, that is 30 into 30 is 900. So here there is 1 0 and here you see 2 0. 90 into 90, 1 0 here, it is 8100. 8100 is 2 zeros. 900 into 900 is 8,10,000. That is, here there are 2 zeros and here there are 4 zeros. So if a number has certain number of zeros here, say 2 zeros or say 3 zeros, it's 9,000, then its square will have double the number of zeros. So if it has 3 zeros here, it will become 6 zeros here. And why is that? Same thing. You do 90 into 90 in like a multiplication. 0 multiplied by anything will be 0. So here it will be 0 in the ones place. Next digit also, because there is 0 here, 9 into 0 is 0. So in this case, because there was 1 0 1 0 here, basically this will be 0 and this will be 0. So the number was having 1 0, you will get 2 zeros in the product or it's its square. If there were 900 into 900, you will see 4 zeros. Or in other ways, you can think 90 into 90 is nothing. 90 you can represent as 9 into 10. This 90 also you can represent into 9 into 10. So it's 90 into 90 becomes 9 into 10 into 9 into 10. You can, because of commutative property, you can take these things together. So it becomes 9 into 9 into 10 into 10. 9 to 9 is 81 and 10 into 10 is 100. So the answer is 8100. So it's 10 into 10 became these 2 zeros. 9 into 9 became 81. So it is 8100. Same way, 900 into 900, that is 900 square, is 9 into 100, this 900. 9 into 100, this 900. So you can take these two 9s together, 9 into 9, and these two hundreds together. So 9 into 9 is 81. 100 into 100, 2 zeros becomes 4 zeros. So the answer is 810000. Right? So square is a pretty simple concept. A number multiplied by itself becomes the square of that number. So that's all in this video, children.
What is 12 squared? Quite a few of us would know that it's 144, but in this video, we will look at a super quick way to square a number. The first thing we need to do is look at the number that is being squared. It's 12. The numbers we will be looking at squaring in this session will be close to some power of 10. By powers of 10, I mean 10, 100, 1000 and so on. So while squaring such numbers, we first choose a base which is close to the number that is being squared. And the base will be some power of 10. Here, 12 is close to 10, so let 10 be the base here. Once the base is decided, we find the difference between the number and the base. That will be 12 minus 10, which equals 2. This number here is really important. It's the difference between the number and the base. We will soon see why. But understand the first few steps really well. We chose the base which is close to the number, and then we found the difference between the base and the number. After these steps, we make a partition. On the left, we write the sum of the number and the difference. That will be 12 plus 2. Sum of the number and the difference. And on the right, we simply square the difference. It will be 2 squared. 12 plus 2 is 14 and 2 squared is 4. We have the answer. 12 squared is 144. Let's review it again. We found the base and then found the difference between the number and the base. After making a partition, on the left we wrote the sum of the number and the difference, and on the right we wrote the square of the difference. And that gave us the answer. But we should be careful about just one thing here. The number of digits we should write on the right-hand side should be equal to the number of zeros in the base. Here, as there is just one zero in the base, we write just one digit on the right. If there were 2 zeros in the base, we would have had to write 4 as 04. Why don't you try one now? Try using the same technique to find 14 squared. Here, we can choose the base as 10, as 14 is pretty close to it. The next step is to find the difference between the number and the base. That will be 14 minus 10, which equals 4. After this, we make a partition. On the left, we write the sum of the number and the difference. That will be 14 plus 4. And on the right, we square the difference. So we write 4 squared. 14 plus 4 is 18 and 4 squared is 16. So the answer is 1816. This is a very common mistake that students make when they use this technique. Don't forget what I told you. The number of digits on the right will be equal to the number of zeros on the base. As there is just one zero in the base, we will have just one digit on the right. So 14 plus 4 is 18 and 4 squared is 16. As just one digit is allowed on the right, we carry the 1 over and write 6 here. 6, 8 plus 1 is 9 and 1. That's the answer. 14 squared is 196. The takeaway here was that we wrote the units digit 6 here and carried the 1 over as just one digit was allowed. Here's the last example which I want you to try. 98 squared. The number 98 is close to 100, so we choose the base as 100. Once the base is chosen, we subtract a number from the base to find the difference. That will be 98 minus 100, and that will be minus 2. We have the base, we have the difference. Now we make the partition. On the left, we have the sum of the number and the difference. 98 plus minus 2 can be written as 98 minus 2. And on the right, we have the square of the difference. That will be minus 2 squared. Will the answer be 964? Don't forget, the number of digits on the right will be equal to the number of zeros in the base. As there are 2 zeros in the base, there will be 2 digits on the right. So 98 minus 2 is 96 and minus 2 squared will be written as 04. 98 squared is equal to 9604. Remember the steps. Base, difference between the number and the base. partition, sum of the number and this difference on the left, and the square of the difference on the right. In the next part of the session, we will solve for squares of larger numbers which are close to the power of 10. I'm going to tell you how you can find whether a number is a perfect square or not. So, we'll start with the basics. A perfect square always ends in the following numbers. This means 1, 4, 5, 6, 9 and 0. So a perfect square will always end in either 1, 4, 5, 6, 9 or 0. This means if you have the last digit as 2, 3, 7 or 8, the number will not be a perfect square if the last digit is 2, 3, 7 or 8. Second important thing, if you have the last digit as 1, 4, 5 or 9. If the last digit of an answer is 1, 4, 5 or 9, then the second last digit will always be an even number for a perfect square. For example, second last digit even. If last digit is 1, 4, 5, 9. I'll give you an example. You take any number just for say 18 square. 18 square is 324. So you can see here the last digit is 4, the second last digit is an even number. You take any random number. Now suppose this is 97 square. 97 square is here 9409. So this is basically the second last digit will either be an even number or 0. I'll also write it or 0. Now if suppose you have 95 square, that is 9025. So the last digit was 5, your second last digit was an even number. You can see whenever the last digit is either 1, 4, 5 or 9, the second last digit will be an even number. However, if the last digit is 6, if last digit is 6, then second last digit will always be odd. Then second last digit will always be odd. We'll take an example. Now suppose you are finding the square of 16. Then 16 square is 256. Last digit was 6. Second last digit was an odd number. If suppose you are finding the square of 24. 24 square is 576. Last digit was 6. Second last digit was an odd number. Further, you are finding an of 56 suppose. Then the answer is the second last digit is your odd number. So this is a very easy thing to remember. Whenever you have the last digit as 1, 4, 5, 9, the second last digit will be an even number. But if the last digit is 6, then the second last digit will be a odd number. Now, one more thing. If the last digit is 5, if last digit is 5, second last digit will always be is equal to 2. This means if you have 5 in the last, then the second last digit will always be 2. For example, I'll take the square of 75. This is equal to 75 square is what? 5, 6, 2, 5. So you have 5 and the second last digit is 2. You take the square of 95. That is equal to 9025. You take the square of 105. You will get 11025.
So the last digit is 2 in each and every case. You take any example, you take the example of 125, it is 15625. The last digit will always be 5. When the last digit is 5, the second last digit will be 2. Now, coming to the most important part of this. Whenever you have a perfect square, the digital sum of that perfect square will always be an odd number or 4. Just try to understand what I am saying. If there is a perfect square, the perfect square digital sum will always be an odd number or 4. What is the digital sum? Digital sum is basically the sum of all the digits that you are having. For example, you take this example 105 square. I'll write it down, write the example quotation first. What was that? If the digital sum of a perfect square is an odd number or 4. Let's see it with an example. These all are perfect squares. You find the digital sum. For the digital sum, what I'll do is I'll add all these numbers. This is 1 plus 1, 2, 2 plus 0, 2, 2 plus 2, 4, 4 plus 5, 9. So the digital sum of this is 9, an odd number. You take this number, 9 to 11, 11 and 5, 16. 16 is 6 plus 1, that is again 7. You take the digital sum of this number, 5, 6, 11, 11 to 13, 13, 5, 18. 18 is 8 plus 1, that is equal to 9. Again an odd number. Okay. Now see this digital sum of this number 56 square. 56 square is 3136, 314, 437, 7 and 6 is 13. 13 is 3 plus 1, that is equal to 4. So the digital sum of 56 square is 4. So you can see that the digital sum of a perfect square will always be an odd number, and in the odd numbers it will never be 5. This means it will take the values 1, 3, 7, 9 or 4. This is a very important technique and very easy way to find whether a number is a perfect square or not. You see the example this 5, 7, 12, 12, 6, 18. 18 is 8 plus 1, 9. You take any example, you take any perfect square, take its digital sum, it will always be an odd number or 4. And it also in an odd number it will never be 5. So to recapitulate what we have seen, a perfect square never ends in 2, 3, 7, 8. The last digit of a perfect square will never be 2, 3, 7, 8. Second thing, if the last digit of a perfect square is 1, 4, 5, 9, the second last digit will always be an even number or 0. Second last digit will either be an even number or 0. If the last digit of a perfect square is 6, then the second last digit will be an odd number. So if suppose you are given a number 256 and 266, and they are asking you which of them is a perfect square, then you can easily say that 266 is not a perfect square, because the last digit is 6 and the second last digit cannot be an even number. So 266 is not a perfect square, that is for very sure. Now the third thing that I told you is the digital sum of a perfect square will be either an odd number or 4. Fourth thing, if the last digit of a perfect square is 5, then the second last digit will always be 2. For 5, the second last digit will always be 2. So this is a very easy method to find the perfect square. I hope you have liked the video. Please.
Now let's try finding the square root of 11,025 using the prime factorization method. Hence, our aim would be to reduce 11,025 into its prime factors. So we write 11,025 here and draw two lines like this. If we know the rules of divisibility well, we can say that this number is divisible by 3,
5 and 7. So we can start with any prime number. Say 5. So 5 multiplied by 2205 gives us 11,025. This number again is divisible by 5. Hence, we write a 5 here. And 5 multiplied by 441 gives us 2205. Of course, you would take a bit more time to find the numbers here, but that's perfectly alright. And remember, we keep just the prime factors on the left-hand side. Now since 441 is divisible by 3, let us write 3 here. And 3 multiplied by 147 gives us 441. This number is also divisible by 3. And 3 multiplied by 49 equals 147. And the only prime number 49 is divisible by is 7. And 7 multiplied by 7 is 49. And yes, we stop here since 7 is a prime number. So 11,025 can be written as 5 times 5 times 3 times 3 times 7 times 7. Hence, the square root of 11,025 can be written as square root of 5 times 5 times 3 times 3 times 7 times 7. The next step is to make pairs of the same numbers. And after we find the pairs, we choose one number from each pair. So we have 3 pairs here. A pair of 5s, a pair of 3s, and a pair of 7s. We choose one number from each pair. So from the first pair, we choose 5. From the second pair, we choose 3. And from the third pair, we choose a 7. And to find the square root, all we have to do is multiply these numbers. 5 multiplied by 3 multiplied by 7 equals 105. Hence, the square root of 11,025 is 105. This part of the problem where we choose one number from each pair is really simple. What we really need to be good at is finding out the prime factors quickly. Here's another interesting thing you need to know. Finding the prime factors of large numbers can be difficult and tedious. So yes, there is a better way to find them, which we will see in the coming videos. There are 2 ways to solve for the square root of a number. We can either use a calculator, of course, everybody would love to use this option, and the other way is to solve it manually. Manually too, we can solve it in 2 different ways. One, by using the prime factorization method, which we have already seen. We split the number to its prime factors and then choose one number from each pair. The other method, which we will look at in this video, is called the long division method. The name sounds fancy, but don't worry, if you follow the steps given in this video, you will never go wrong. But why can't we just use prime factorization every time? Well, if the number is large, it will take us a lot of time to reduce it to its prime factors, and the chances of going wrong are very high. Hence, prime factorization is useful only for small numbers. And for large numbers, we can use the long division method. Let's solve a couple of examples to understand how the long division method works. Look at the number 8,281. If we have to reduce this number to its prime factors, we would first have to think of all the divisibility rules and so on, and that would take us a lot of time. So for such large numbers, we use the long division method. The first thing we need to do in the long division method is to draw lines like this. A line on top and a line to the left of the number. When you draw a line on top of the number, remember to leave some space above the number. Once you're done drawing these lines, you're ready for the first step. The first step is to mark pairs of digits from the unit's end. The unit's end is the number 1. So we mark pairs of digits from right-hand side. This becomes our first pair from the right, the number 81. We continue to mark pairs till we cover all digits of the number. The next pair will be 82. So the first step was simple. We just mark pairs from the right, which gives us 2 pairs, 82 and 81. Now we look at the first pair from the left, which is 82. In the second step, we have to find the perfect square which is equal to or lower than 82. Since 82 is not a perfect square, we choose the perfect square lower than 82. The perfect square just lower than 82 is 81. Even 64 is a perfect square lower than 82, but remember, we always choose the one which is closest. We know that 9 squared equals 81. We just found out the most crucial number. It's the number 9. 9 is basically the square root of the closest perfect square. We write the number 9 here to the left of the number. This was actually the most important step of the long division process, to find the first number. The next step is one of the easiest steps, but it's a step where most of the students get confused. The step says multiply above and add below. But what do we multiply and what do we add? It is the same number, 9. Let's focus on multiplying above first. We multiply 9 with 9 and write the product here. So the 9 you are multiplying is written on top. Now let's come to add below. We add 9 with 9 and write the sum underneath. 9 plus 9 gives us 18. We multiply the same number with itself above and wrote the product here. And we added the same number with itself and wrote the sum here. Remember, when we multiply or add, we're doing the operation with the same digit. In this case, it's 9. So we have completed 3 steps. First, we found the pairs from the right. Second, we found the perfect square and wrote its square root here. Third, we multiplied above and added below. If you observed it well, you could see that I have left some space next to the sum of 9s. That space is kept for the box. So we draw an empty box here, and inside this box we will be writing some digit. Our next aim is to find this digit. The next 3 steps are super simple. We just subtract the product from the number above it. The product we got was 81. The number above it is 82. We subtract 81 from 82 and get 1. And then we get the next pair down. The next pair is 81. So we write it next to 1. Then we draw the same box above and below. Above, we draw it next to 9, and below, we draw it under the original box. The digits contained in each of these boxes are the same. The next step, according to me, is the most interesting step of the long division method. We use trial and error to find the digit in the boxes. We look for the product of 2 numbers, which gives us 181. This is how the product should look. What number do you think we can write in the boxes to get 181 as a product? Remember, the digits in both the boxes have to be the same. Yes, 181 multiplied by 1 gives us 181. So we have found the digit in the boxes. It's 1. After we find this digit, we go back to the third step and follow the same procedure. Multiply above. So we write a 1 and a 1 in these 2 boxes and get the product of 181 and 1 as 181. Then we add below. We add 1 to 181 and get 182. Then we subtract the product from the number above it. So we subtract 181 from 181 and get a 0. The moment we get a 0 here and there are no more pairs left, we are done. But wait, where's the square root of 8281? Well, it's the number you got on top. It's 91. The square root of 8281 is 91. Trust me, it's not difficult. It's just a little lengthy. Let's review what we just did. We marked pairs from the unit's end, which gave us 2 pairs, 82 and 81. Then we choose a perfect square which is equal to or lower than the leftmost pair, 82. We found out that 81 is the closest square. We write its square root to the left. Then we multiplied above. 9 multiplied by 9 equals 81. And added below, 9 plus 9 equals 18. And with 18, we leave space for one more digit. Then we reach the 3 simple steps. First, we subtract the product. 82 minus 81 gives us 1. Second, we get the next pair down. And then we draw the same box above and below, which will contain the same digit as the original box. And to find the digit in the boxes, we use trial and error and get 181 multiplied by 1 as 181. So the number in the box will be 1. After we find the number in the box, we go back to the third step. We multiply above. 181 multiplied by 1 gives us 181. Then we add the same digit below. 181 plus 1 equals 182. Then we subtract the product. 181 minus 181 gives us 0. And since there's no pair left, we stop and get the square root as 91. Remember, inside the two lines, we always subtract, and outside, we always add. To get a better idea, see the second part of this video in which we have solved for the square root of another number using the same procedure. This is where we left off in the last video. We followed these steps to get the square root of 8,281 as 91. Now let's try solving for the square root of 6,084. Before we start off with the steps, remember to draw lines like these next to the number. After this, go to the first step. We mark pairs from the unit's end. So we draw bars over 84 and 60. So the two pairs we have are 60 and 84. Now we look for a perfect square which is equal or just lower than the first pair. The first pair is 60. Since 60 is not a perfect square, we look for a square closer to it. 49 is a perfect square close to 60. So is 64. But remember, we choose the perfect square closest and just lower. So 49 is the perfect square we're looking for. And we have to write the square root of this perfect square here. We know that 7 squared is 49. And hence we write a 7 here. You should know that finding the first number is the most important step of this process. If we go wrong here, then the rest of it will definitely be wrong. In the next step, we multiply above and write the product here. So 7 multiplied by 7 gives us 49. And then we add below and draw a box next to it. 7 plus 7 gives us 14. And we leave some space for the box. Next, we follow out 3 simple steps. Subtract product. 60 minus 49 gives us 11. Then we get the next pair, which is 84 down. Then we draw the same box above and below. And at last, we reach our favorite step, finding the digit in these boxes by trial and error. We want the product of two numbers to be equal to 1,184. But the product will look something like this. And we have to use trial and error to find the digit in these boxes. Okay, now here's a trick you need to remember. This trick can be used only when there are no more pairs left. Here, since 84 was the last pair we brought down, we can use this trick. We know all the boxes contain the same digit and any digit from 0 to 9 can be in it. That doesn't mean we try all digits one by one starting from 0 until we reach 9. Look at the units digit of the result we want. It's 4. So the product of the two digits in the boxes must have 4 as the units digit. So we narrow down our possibilities to just two choices. 2 times 2 equals 4 or 8 times 8 equals 64. Both have the units digit as 4. It will either be 142 times 2 or 148 times 8. The digit in the box will either be 2 or 8. The first product gives us 284 and the second product gives us 1,184. Exactly what we wanted. The digit in the boxes will be 8. After we find the digit in the box, we go back to the third step. We multiply above. 148 multiplied by 8 equals 1,184. And then we add below. 148 plus 8 gives us 156. Then we subtract the product we got from the number above it. 1184 minus 1184 equals 0. We stop since there are no more pairs left in the number. The number at the top is the square root. We get the square root of 6084 as 78. How do we check if our answer is correct? One way is to multiply the answer with itself and see if we get the original number. The other way is interesting. This number here will always be twice of the answer. 156 is 78 multiplied by 2. In the previous example too, 182 is the double of 91. Wait a moment. What if we had 5 digits in our number? After choosing 2 pairs, only 1 digit will be left. We will see an example based on 5 digits in another video.
This is your assignment time, children. Complete exercise number 1.4 up to Roman number 6 after seeing the videos thoroughly. I am posting you the answers for the given sums also after this video session. Thank you. Hari Om.
पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः हरि ओम श्री गुरुभ्यो नमः हरि ओम